Yes.
Hi.
You're great.
How's everyone doing? Woo! So Joe McCray and I first met in person. I heard of the myth, the man, the legend before that. When we were at BrewCon, we hung out, and I'm like, if I ever have a conference, I want Joe to come talk at it because he's awesome. And we had a lot of fun. So that's why you're here today. So Pat, you want to get a little more about Joe's background, or? Okay, we're all set. So did you want to say anything before we get started?
Joe.
Oh, okay.
So, when Paul and I were putting this together, we decided the way that we were going to get our speakers was Paul was going to get all his really good friends to speak. And as we were going through it, he said, who do you want to have at the conference? I said, the one guy I want to have is Joe McCray. So I made sure that Joe McCray got invited, and I'm super excited that he's here. He's an Air Force veteran, and he's also the CEO of Strategic Sec. Woo.
Now after that, you can't suck. So
I know. I make it so freaking hard.
I will cry, Joe.
You will cry. I believe this, man. I believe this. Okay, guys. So everybody knows me. I'm the black guy at security conferences.
I was thinking about that line.
Yeah, I need to trademark this. I really do. I need to trademark this. It's what, my second time here? I did CohawkCon. Prior to that, and I'm hanging out. You kicked us to the curb at CohawkCon, didn't you?
I had recovered from surgery. Thanks for reminding me.
No problem. You're figure things out. You know, that's what friends are for. So, I'm trying to do this exploit dev thing because really I'm trying to kind of demystify some of this stuff. How many of you, when you look at the exploit dev stuff and you hear people talking about reverse engineering and exploit, and as soon as they start talking about like EVP and EAX and IDA Pro, and all of a sudden you kind of, oh my God, you get a little like, all that, and is it just me? No. Okay, you do? All right, so my goal here is to try to make this so that something that you can follow and something you can do. I am by no means an expert at it, but when I started to learn it and finally like started hanging out with people who do it, it really kind of hit me like damn, like I can do this. This isn't like rocket science. Like you could actually follow this. It's not that bad. So as far as like dealing with things like assembly and all that, too fucking bad. Yes, you need to learn assembly. Is it that bad? No. Nowhere near as bad as marriage. You ever say some shit with your outside voice that you meant to say? That didn't go the way I wanted it to go. You know what I'm saying? It's not that bad. It can be bad, but it's not. Okay, let me just start the demo. Okay, guys, so basically we got this app. So it's this quick little vuln.c app. So it's this little vulnerable app that accepts commands. And it's just an exe file. We're going to fuzz the app. We're going to try and make the app go boom, right? So we've got said app. We're going to open up new command prompt. And I'm going to netcat into the app. The app runs on localhost port 9999. So when I connect to it, any day now, thank you. All right, so I connect to it and you see it's like, hey man, received connection. Now this is one of those intentionally vulnerable apps. Now when you're first learning this stuff, you want to play with these. But just like WebGoat, you want to very quickly get away from vuln.c, intentionally vulnerable software. Because you're going to learn that real software is way more interesting and way more fucked up. Real software is quirky as hell. When you play with these vuln.c type things, you're like, oh, well, I do this and then boom, it blows up perfectly. Real software, you need alcohol. That's all I'm saying. I write my best code when I'm drinking. Okay, so.
So, Joe, what do you usually drink when you're drinking?
Well, rum and coke, of course.
Rum and coke.
Oh my God, my bitch. Oh, man.
Is this the first time you mix a drink live on stage for a human presentation?
I think that would be yes. That would be yes. Okay, so I'm going to issue the help command. And when I issue the help command, you see that I get this list of methods. Sorry about that, guys. I gotta work on something real quick.
Good stuff, something stuck in your throat there.
There we go. All right, so just like any other server, you know, if you netcat into a web server and you issue the options command, you get a list of all the options that the server supports. Some people call these methods, some people call these verbs. But essentially what it is you've got a parameter that takes you know, an argument, and you know, usually it takes like some sort of string, right? So we've got help, stats, rtime, ltime, srun, trun, gmon, all these different things. So what we want to do is we want to crack open some code written in Joe's favorite language, which is Python. Now, I absolutely love Python, and if you don't love Python, you're free to leave right now. No, I'm really not kidding. You can get the fuck out. Python, really. Okay, so, all right, let's see. I gotta get this so you guys can see it a little better. There we go. All right, so that's kind of, where's our video guy? All right, well, anyways, that's not uffer, that's buffer. So, you want to talk to an IP import, so you're going to import the library socket. So you say import socket, and then you're going to have buffer, and you assign it to A. So anytime you see buffer, mentally just say to yourself A. Cool? A. All right, every time you see counter, just tell yourself 50. Counter? 50. Too easy. All right, so while the length of buffer is less than or equal to 100, we're going to buffer.append A times 50. Too easy. That gives us 50 A's. Now after that, we're going to increment counter. So counter now equals 51. Well, not really 51 because it's counter. I've been drinking. Come on. All right, so counter equals counter plus 50, so that makes it 100, and we're going to keep looping through it. Cool? So you start with 1A, then you go to 50 A's, and you keep incrementing all the A's. Make sense? Awesome. After that, we have a list. So we've got a list of commands, and now we've got help, stats, rtime, ltime, srun, trun, all of the commands or methods that we see that the server supports. And we're going to start sending those commands. So you see the next line is for command in commands, and then we've got this nested for loop. For buff string in buffer, print fuzzing that command, and then the length of the command. And now the next line is how you instantiate a socket object. You can remember that this is how you instantiate a socket object, but you can remember whenever I need to connect to an IP import, I need that line. What works for you? That line? Cool. So you want to connect to an IP import, you need that line. After that, s.connect, we connect on port 9999. Here's that receive, that welcome to vulnerable server. And then after that, we send it. Too easy. So we've got our vulnerable app, and then we run our little fuzzer. Whee! And then it goes boom. Now, here's where you get to do the consulting thing. We've actually identified a vulnerability. Right? And you can look over at the developer and go, I broke it. Because that's really all that matters in life, breaking things. That's why I joined this whole gig. I really just wanted to break stuff. So I run the fuzzer again, the damn thing blows up, and you notice it looks like it blows up on the trun function, yeah? Somewhere around like 3,000, 3,500, 3,400 A's, something like that, thing goes boom. Okay, now the next thing we want to do is we want to crack open a debugger. So, everybody, debugger. Ooh. Yeah, I know it's interesting. I know. I like this stuff too. Kind of like, no, not really, not that much, no. Okay, so guys, when you got a network, right, take your network cable, cut that bad boy, look down in it, wire sharp, yeah? Okay, you have your computer, open up the thing, CPU, cut the damn thing open, look down in it, debugger. Cool? All right, so we got our debugger, we're gonna attach to a running process. So we've got the vulnerable server running, I'm just gonna attach to it. And now, everybody, that is assembly. Ooh. Yeah, I really like this stuff. I really like it. Okay, assembly's not that bad. Now, like I was saying, assembly's not that bad. Now it's called the back. Okay, somebody have a couple of books? I'll take what I can get. Thanks. All right, guys, look. Assembly is easier than you think. Assembly can only do one thing at a time. Now, he's got a young child. This is what you wish a young child would do. One thing at a time. Assembly is easy. Look, man, workbench. If we want to work on the bench, we push something onto the bench. We push something else onto the bench. When you want to work with it, you call it or you ret. So I want to work, so I push, ret, or call. Too easy. If I push something else on top of it and I want to work with the one that's on the bottom, I need to do what? Pop. Pop, and what? Ret or call. Too easy. Make sense? Okay, so when you're looking at code and you're seeing that he says something like, all right, look, man, I'm going to do a not right now. Well, first I'm going to return, then I'm going to not, don't do anything. Right? This is what you're wishing your kid, right? Just don't do anything.
Knock them to death every night.
Just knock them to death. Right? And then like push EDI. So you're seeing here, all this is more than one workbench. So every time you have EAS, EBP, ESI, that's a different bench. You just got different benches. A register is a place where you do stuff. That's all that is. So when people talk about, oh, this is going on in EAX or EBP or ESI, it's just registers, and they're all relative. Dude, you got the stack pointer, the base pointer, the stack index, the accumulator. All they are is relative, right? ESP is usually 4 or 8, sometimes 12 bytes away from ESP. EIP. EBP is usually 4 bytes behind EIP. So once you know where one of them is, you can kind of start to figure out where all the rest of them are. That's it. So all it is a place where you do work. Generally, math. So over here, if I'm moving like below the push EDI, I'm going to move this D word pointer ESP plus C into EDI. So I'm going to take ESP plus C and move it to EDI. Make sense? After that, you're going to be like, all right, well, let me move this D word pointer ESP plus 8 into EDX. Right? And literally that's all that's going on. After a couple of instructions, you'll see something that says, hey, let me OR this. Let me OR EDI versus EDI. Or the JE, let me jump if this equals something. You might see a J and Z, like jump if not 0 from the instruction before. That's really all that's going on. It's one instruction at a time. So you can look in the values of the registers and see what's in each register so you can know what's being moved from one workbench to another. Make sense? Okay, cool. Down here, down in the bottom right, we call that ESP. That's the stack. Okay, easiest thing you need to remember. EIP is what's about to happen next. Okay, EIP, what's about to happen next. Too easy. So whatever's about to happen, that's usually an EIP. ESP, the stack pointer, that's the workshop. Normally, whenever we're working, work is usually done in ESP. Math is usually done in EAX. It's not always the case, but most of the time, that's how it works, right? So down on the bottom of the corner, the whole bottom right corner, that's all ESP. So you're just looking at everything that's working down in there. I call this the Wireshark pane, for lack of a better word. This just shows you the hex view of whatever's going on. You get a little bit of hex, a little bit of ASCII, you can see what's going on. Make sense? Okay, so you look down on the bottom right corner, my debugger's paused, he's not running. So I'm going to say Control F2, F9. Now, my application is running. Let me close that. There's my application running. I'm going to run my fuzzer again. So I go fuzzer, whee! I have fun, because this is the actually only enjoyable part of my job. So you're watching the fuzzer, just have a grand old time, and then the damn thing blows up, right? But now when we look, we see we have A's in EAX, we have A's in ESP, and more importantly, we have A's where?
EBP.
EIP.
In EIP. And EIP is what's about to happen
Next.
So I got my A's into the area of memory that's about to run next. Most people, when they think of a buffer overflow, they think small can, large can, right? pour large cup into small cup, spills everywhere, we have non-described buffer overflow. That's not really what's going on. You're gonna pour large can into small can, yeah. But then when the stuff spills over, it needs to spill over into the seat that's about to run. Make sense? And then in that seat that's about to run, we put our code. Cool? All right, so now that I got that, the thing blew up, I'm happy. I'm gonna control F2, F9. I'm gonna go back, and now what I wanna do is isolate the crash. So if I isolate the crash, let's take a look here. Now the code's a lot simpler. Is there anything you can do to get that corner?
I can't really control it.
All right, cool. Let me do this.
Okay, actually, that's good.
All right, so now in this case, you see buff string is what, guys? It's just 5,000 A's. I'm not doing every different command, right? I send 5,000 A's. All the rest of the code is the same. So this is isolating the crash. What I want to do is I want to prove that if I send 5,000 A's to the trun function, that it overwrites EIP. Does it?
Yes.
Yes, beautiful. So control F2, cool, then F9, let's try this again, class. Control, then, thank you very much, good job. There'll be a quiz. All right, now, EIP is only 4 bytes. EIP is only 4 bytes. EIP is only
4 bytes.
4 bytes. Now, I sent 5,000 A's. Somewhere in them 5,000 A's is the 4 bytes that overwrote EIP. Now, what we can do is we can do something called binary diffing. Let's send 2,500 A's, 2,500 B's. I'll look at EIP. If I see B's, I know it's in the second 2,500 bytes, right? Then after that, I can start cutting it up in more chunks, right? Now, within 7 iterations of cutting it in half, you'll come up with the exact 4 bytes that may overwrite EIP. Who's like, cool, but I'm lazy? Yeah, lazy? Sweet. So, I'm lazy too. So what we're going to do is we're going to send what?
Pattern.
Exactly. We're going to send a cyclic pattern of non-repeating data. Everybody? Damn, that's smart. I wish I came up with that. Okay? So you're going to send this non-repeating pattern, and when it overwrites EIP, you're going to go, okay, whatever that number is, I'm going to calculate the distance to that number. That should be my distance to EIP. Cool? Cool. All right, so what I do, I've got my debugger running. I run my code. I look at EIP. All right, somebody read to me what's in EIP. What's the numbers? 39, 6F, 43, 38. You're wrong. Try it again. 38, 43, 6F, 39. Why? Little Indian. Who went to college and was like, I will never use this. I don't know why you are telling me this. Because when we talk big and little, I'm not thinking comp science. Right? Right? We're not thinking, you know. Okay, yeah, that was a joke, but that was supposed to be fun. Okay, control F2 and F9. Okay, so we got those numbers, and what we're going to do is we're going to look at our very next script, and we see here that you guys read it right? It needs to be bass backwards. And that is an 8, capital C, lowercase o, and then the number 9. So I'm just going to chop off that string and send that string as is. And then I'm going to print the length of it. So when I run this script, it should tell me my distance to EIP is what? I need to talk to the video guy.
I control the recording, not that screen.
Okay, so my distance to EIP is what? 2006 characters, right? So what I want to do is I want to test this, and I want to see if that 2006 characters really does overwrite it. So if I send 2006 A's, what's immediately after that? 4 B's. So EIP should now be 42, 42, 42, 42. This would prove that I have control of EIP. So we got our app running. We send this bad boy, we take a look. Do we own it?
Yep.
Sweet. Okay, now we do the cool part. Inside of EIP, you put random interpreter shell. Kind of, sort of, but not really. Okay? Houston, we got a problem. Right now, size does matter. You can't fit all of the code to say open a command prompt in 4 bytes. So what we gotta do is we gotta find a place where we can put all that stuff called shellcode, and then we probably wanna jump to it. So if you noticed when I ran the script the first time, everybody control, F2, and then F9, awesome. I'm gonna rerun script 2. So I rerun script 2. If we look down in ESP, is ESP full of our A's?
Yes.
So we have enough space for shellcode in ESP. So we probably want to use a jump ESP instruction. Make sense? So I want to search memory for a jump ESP instruction. So let's do that. Come on, man. Work with me. Thank you. All right, so what I'm going to do is everybody see this E right here? So this E is for executable modules. I'm going to click the E. And when you guys look here, you notice we have DLLs, right? Okay, so here's system DLLs. And here's a third-party DLL. Something to note, how many of you have used Metasploit or Core Impact or Canvas, and it says this exploit is for Windows XP Service Pack 3. This exploit is for Windows 7 Service Pack 1, yeah? Yeah. Okay, what happens is when the attacker searches for that jump ESP instruction, if he gets it from a system DLL, then he's going to be dependent on the platform that he's exploiting. What that means is when Microshaft deploys a patch, these system DLLs may change. So now that jump ESP instruction, what? That's fine. That jump ESP instruction might not work anymore. But what if we get it from ESS Func? That's a third-party DLL. So now you can service pack as much as you want, and it shouldn't affect your exploit. Does this make sense, guys? So when you're seeing that exploit is highly dependent on the service pack, more than likely they used a system DLL. If you see an exploit that has a wide range of targets, like Java, more than likely they used a third-party DLL. Everybody with me? So now we start talking about all that third-party patch management and all that stuff, starting to kind of come a little full circle, right? All right, so what I'm going to do is I'm going to double-click ESS Func, and now you'll see that we're actually inside of that DLL. So we're inside of that DLL looking at the assembly, and now what I'm going to do is right here, I'm going to search for a jump ESP command, and I find it. What I'm going to do is I'm going to set a breakpoint on it. So you've got your program running, and if you actually hit this, that breakpoint will turn red. Cool? But it's already red. You actually said something. Okay, so it's red, it'll turn black. Black is good. Okay, it is. All right, so now what we want to do is we want to look at this code, and we'll see now our code's pretty much still the same, but a couple things have changed. All right, bus string 2006As are ret. There's that jump ESP instruction that we just found inside of ESSFunc.dll. We're going to send that, we're going to overwrite EIP with the jump ESP instruction, and then we've got 990 C's still remaining. We'll look and see if those are in ESP. So I'm going to run this bad boy. My breakpoint hit. See it?
Yeah. Yep.
It's black. Okay, now when I look here, when we look in EIP, we see EIP is the same address of that jump ESP that we found. Beautiful. We see that ESP has our C's. We scroll down here. ESP is full of all C's. 41's an A, 42's a B, 43's a C. This is beautiful. So now we just swap out those C's with shellcode. So you just use MSF payload, and then you build, you use MSF payload, and then you build shellcode. So now you see that it's the exact same exploit, and then we just inserted a payload, and that payload is inline assembly instructions that just say open a command prompt on this port. And with Metasploit, you can generate just MSF payload, Windows, shell bind, TCP, shell reverse, you know, whatever you want. Okay, so that's that. And let's run the daggum thing. So we start this, run this bad boy, open up a new command prompt, and now let's netcat localhost port 4444, and boom, the box is owned. Got a shell on it. Okay, so simple Stack Overflow. All right, so that one's pretty easy, right? That's like your first basic intro to an exploit, right? After that, then we want to start trying to get into something that's like a little bit more modern. So with that in mind,
Need more cowbell.
yeah, I need more cowbell. Okay, so with that in mind, let's try and check out something else here. All right, I'm gonna have to come up with a better way of doing that. All right, so this is a Firefox exploit. Okay, it would be a Firefox exploit if I could get Notepad++ to open. Okay, better. All right, guys, so if you look here, you see that we've got this HTML file, right? All right, now it's a Firefox exploit, but specifically what I'm going to attack is VLC. Now, a lot of people ask, why do I do it this way? You see that we've got buff, and what you're going to do with buff is you're going to say for i's equal to 0, while i's less than 1250, increment it, and then you're just going to say buff unescape is these 41s. So 4 times 1250, 5,000. We've got 5,000 A's. Everybody with me? Okay. Now, if you look where it says bar track, you see that SMB path. So SMB path example.com 00000/foo, and then right at the end of it, buff. What happens is VLC can read videos off of a network share. The problem is it doesn't validate the length of the file name when it does that. So we could give you an MOV file, right? We could give you an MPEG file, right? But if I just gave you an MPEG file, an MOV file, or something like that, how do I know that you open it with VLC, right? You might open it with Windows Media Player, or Winamp, or QuickTime. You know, I don't know. But if I serve it up to you in a browser, and through the HTML page, I say, look, document.write, that's how JavaScript writes something to the screen, embed type application what? XVLC. Through the browser, you can tell the browser what application to load. So even though Firefox can be completely patched, and you use an unpatched version of VLC, you can now force VLC to load even if he's got another media player installed. So now I hope that that third-party patch management is starting to really kick in. Now I hope you're thinking about it. Because you're like, well, I mean, most of the customers in our environment use X, but if we have third-party applications, you realize that your browser can instantiate them. So if someone serves you up a browser exploit, you click on that link, he can force whatever application that he wants to load. And in other circumstances, he can even force you to download and install an application and then run it. A really good one that we've done on a pen test a few years ago was we actually served up a vulnerable ActiveX control. ActiveX controls are signed using something called Authenticode, right? So you can't just give someone a fake one. But what Microsoft did this beautiful thing is you can have a brand new version of an ActiveX control, and if I serve you up a legacy one for backward compatibility, Microsoft will let you install it and run it. So you can serve up the vulnerable ActiveX control and then turn around and exploit it. Okay? All right, so.
Hey Joe, I have a question. So when you do that, tell the Firefox browser to instantiate VLC, does the browser warn the user and say, "Are you sure you want to launch this application?"
Oh, not just no, but hell no. No.
But like when it instantiates iTunes, it asks me, "Do you want to launch this application or not?" In certain browsers, but Firefox and Windows.
Okay. All right. So now we're going to switch the game up. We're going to start Firefox, and now we're going to man up, guys. So you were using the pretty little debugger, right? The cutesy one. But now, time to go hard. What I want you to do, I want you to step into Win Debug, right? Command line, commando. We're gonna go hardcore now, man. So, attach to the process, G to go. Now, what I want you guys to notice is once I launch Firefox and I browse to this address, watch how many DLLs load. So let me just make sure I'm serving up the right one. So you got Firefox going over here. Let's zoom in on this sucker. Now you guys see all those? All those VLC DLLs. Isn't that cool? You're like, wow, my browser just loaded up all that stuff. And you're like, yeah, it sure did. And then what's the cool part? If you get back here and look, EIP, 41414141. Right? So we got our A's into EIP, same as last time. So, super cool. What I'm going to do, I'm going to kill this thing, start up a new Firefox, start up my debugger again, F6. G to go. Let's go check out our next page. All right, so I gotta figure out how to make this display better. Okay, does somebody know Windows so I can make this damn thing show up?
You might mess around with the
Hit the corner and drag.
refresh rate.
If you change the desktop resolution, maybe.
Awesome.
You should probably just reboot it.
I could probably just reboot, huh? Okay, so let's try this. You see my first variable is shellcode, and my shellcode is just CCs. Now CCs is a software breakpoint. So what you do is you've got this long string of 32 CCs, so you just software breakpoint. So once this hits, your computer will freeze, right? So you're gonna see int3 CCs, it just means stop. So this is what we're gonna do for our shellcode, dummy shellcode, where we fill. And if I can get EIP to run the CCs, I replace the CCs with real shellcode. Make sense? All right, so now if you look, my very next variable is called spray. So I've got spray, and that's all 90s. Okay, what did I tell you 90s were?
No.
Knops, so they don't do anything, right? So if you look, you got all these knops, and then your very next thing says do spray plus equal spray, while the length of spray is less than C and 4 zeros. So if you go C 1, 2, 3, 4, and then flip that bad boy to decimal, that number be huge. Yeah? Okay, so 786,432 knops. I'm making a lot of knops, right? So you're making this huge amount of knops. So you got this massive amount of knops. Then right at the very end, what do you notice that you do? Right, so you got 700,000 some odd knops, and right at the end of it, a what? Your shellcode. So if you land in those knops, what are you going to do?
Slide.
You're going to slide, right? There's your knot slide. You're going to slide way into that, right? Now, what gets really cool is right here, I make 50 of them. So you're like 700,000 knops, shellcode. 700,000 knops, shellcode. 700,000 knops, shellcode. 1 second.
So Ed SCOTUS had a sled for his kids, and he wrote knob on the bottom.
That's hilarious. So 700,000 knots and
Shellcode.
Awesome. So now, what if you land over here somewhere? You're gonna what? Slide to. Well, what if you land over here somewhere? You're gonna slide to. So no matter what, as long as you land somewhere in those knobs, you're gonna slide all the way to your shellcode. This is called a heap spray. You're spraying the heap with this knot sled shellcode combination, so that if you jump anywhere into the heap, you just slide straight to your shellcode. So that's script number what, 1? So I'll change that. I'll serve up script 1. Whee! I gotta love that part. I'm sorry. I just really do. Okay. All right. So hanging out in the debugger. Now, if I dd EIP, you can see. Oh, sorry. Still thinking about something. Go ahead, man. Catch up to me. Did you guys blow up my computer? Oh, there we go. Now you're working. Okay. So if I dd EIP, you can see that EIP is overwritten with 41. If I dd ESP, you can see that the stack is all full of A's, right? Okay, but now, what if I dd 04040404? I got nothing there, right? If I dd 050505, whoops. Is that 4 5s?
Yep.
Awesome, thanks. Nothing there, right? 06060606. What's there?
No offset.
Nops. Or 07070707. More nops. So now I found that patch in heap memory where my nops are. Now, a lot of people ask me about heap memory. If you have an application and you just like Excel and I just start moving cursors to the right, how many new cells does it create? A lot, right? Right? If you just start moving it down, how many new cells does it create? A lot, right? It creates them as you need them. That's heap memory. It's dynamically allocated memory. How many of you have a job where you receive the PowerPoints from hell from your boss? Right? And PowerPoint's just like, oh God, no, not this one. No, not this one. It's 90 meg, good God, how did the email server even let it get to the inbox? Right? That one, right? Don't act like it's just me. I've worked here, I had a job once. I remember. So you've got applications that have to make copious use of heap memory, right? The Office suite, PDFs, browsers, right? How many of you have gone to a page and you remember those dial-up days where that button was like, right? What's happening is your browser just has to just render. He doesn't really know, how much data is coming. He just starts rendering. Your media player, it doesn't know if it's a 2-minute movie or a 2-hour movie, right? If it's a home video for me, 2 minutes. No, my media player doesn't need to know. He knows it's real. I'm older. Good God, man. I go, what? Why you gotta look at me like that, man? Don't put me out like that, man. You're gonna be old too someday.
Joe, when he makes fun of my age, I say that, except I follow it up with, if you're lucky.
I love this guy. Okay, so we'll start our Firefox, we'll start our debugger, 6, attach, G to go. Now, what we want to do is we just want to look at another script, and we'll see that the only change I've made is instead of sending this overly long string of 41s, I'm going to send an overly long string of 06s. Because when I overwrite EIP, I want EIP to think that's an address to jump to. When we look, did we see our NOPs in 06s? Yeah, so if we overwrite EIP with 06060606, he'll jump into that area of memory where all of our NOPs followed by shellcode is.
How did you know to look in 060606 for that?
Because you saw me go DD01, and you just keep going through till you see
You're
it.
just going through different tiers.
Yeah, and you just keep looking out, okay, there's my shellcode. And what you can do is you can just keep, making the shellcode larger and larger so it's faster to find. Size doesn't matter. That's funny. Okay, so we'll serve up script 2. Browse to this bad boy. Okay, and boom, right? If you see that 06060606, okay, gotta wait for the debugger to catch up. There we go. So do you guys see? Now he landed in 060606. So now the only thing that I'm going to try to do is I'm just going to try and replace that with real shellcode. So let's start another command prompt. I got a netcat listener going here. I got a netcat listener going for port 4444. And the only change that I made was instead of just that shellcode of CCs, now I've got real shellcode that kicks back a reverse shell. So we want to hit that. We want to restore. And let's make sure we're rerunning the right script. Awesome. Come over here. Let's hang out for a little bit. This sucker's a little slow. Cross your fingers and hope that this demo works. Everybody, hope, 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 hope. If it doesn't work, it's his fault. Okay, let me check over here. Oh, that sucker looks like it's working. Yay! Okay guys, so I'm hoping that as you start to look at this, it's not that bad. You know, does the assembly suck? Yeah. You know, does the programming suck? Yeah. But as long as you can kind of understand, you know, okay, you know, I'm looking for DLLs, I'm looking for, you know, space in the heap where I can you know, put my shellcode. It's not that bad to follow stuff. So if you're learning exploit dev, these are your first types of exploits that you're going to learn. A stack overflow, an SEH overwrite, a heap spray, that was this technique. And then after that, we start talking about mitigations. Things like DEP, data execution prevention. Things like safe SEH. Things like ASLR. So I just need you guys to think about it this way. Remember when we landed in our shellcode? Okay, DEP, we land in it, everything will work, and it won't run. Right? The stack is marked non-executable. That's DEP. ASLR, you remember we needed to calculate our distance to EIP? What if every time you rebooted, the distance changed? Make sense? So that's what's going on with today's exploit development. So once you learn these, then you can start getting into how DEP bypasses work. You can start getting into how to build rock gadgets and all that kind of stuff. All it is, when you hear a lot of people talk about exploit dev, it's just a lot of tricks. That's really it. That's it. It's just a ton of tricks. You know, you're dealing with DEP, you're dealing with ASLR, you're dealing with /GS, you're dealing with safe SEH, and you've just got to do all these tricks to get through all of that, and that's all it is. But for me, you know, finally learning this stuff over the last couple of years, because I've been learning this stuff 4 years now. I've been in the security community 12 years, and I was so afraid of this stuff for years. Just, oh God, I don't want to do assembly, and you know, the eggheads do that stuff. You know, the ultra nerds, those guys do that stuff. Anybody can do this. It's not that damn hard. And all that shrouded in mystery bullshit that all these guys try to do with this stuff is just that. It's bullshit. If you really sit down and do this, you can learn it. SecurityTube, how many guys are familiar with that website? SecurityTube.net. Go through the exploit research mega primers. They're wonderful. Corland.be, are you guys familiar with that? Peter Van Eckhout, wonderful tutorials on this stuff. Both of those websites really kind of bring it down to where it's manageable. There's another website, I think it's called opensecuritytraining.info. You guys familiar with that one as well? It's another free website where they walk through a lot of this stuff. They do like the life of binaries and all that. Between those three resources, oh, and pentest.cryptosity.net. The Poly EDU guys with Dino Dizovi and Alexander Satarov, all those resources I just named are free. You can learn all this stuff for free. You can learn it, guys, and you're going to find that when you're talking about vulnerabilities at work, you're really going to understand why vulnerabilities are as important as they are. When you're on pen testing, you're trying to make your exploits work, you'll be able to debug a lot of your exploits. You're going to be surprised to find how horribly written the overwhelming majority of exploits on the market are, and trivial changes that you can do to make your exploits more reliable once you learn this stuff, and it's not that bad. So I'm hoping that that helps. Does anybody have any questions for me? What's up, man?
I actually do have, like, I went through the security tube. I'm starting the research primer.
Yeah.
But what I found helped is if you, like, follow his, like, basically at the beginning of that video, he recommends you watch the assembly primer
Sure.
first. Like, that was just so key. Like,
Yeah.
assembly primer, buffer overflow primer, and then exploit dev, and it was set.
And it was a lot easier to follow.
Totally, yeah, it was like, it just one built perfectly on top of the other.
Yeah, good.
So I definitely recommend.
Can't hate that. Any other questions? What's up, man?
What does a tool like IdaPro give you that you can't do with these debuggers and Python scripts?
A much fancier GUI. That's it. I mean, at the end of the day, man, I'm really not an IdaPro fan. I'm not one of those groupies for that shit. It's just the most confusing fucking debugger I've ever seen in my life. There's so many fucking buttons and shit. It's never. Okay. Bear with me, and I hope I don't offend anyone. But I'm in Best Buy, right? And I see my next wife. It's an 82-inch TV. This thing is awesome. I sit down, right? And I'm like, whoo! I call my girlfriend, baby, get over here, right? She's like, what? Woman, just get over here. So she comes over, right? And you know, my girlfriend. She stands there, and she's got to have an attitude because I'm a black woman. So she's like, what? And I'm like, man, woman, look. She's like, what? I'm like, look at it. What? I'm like, look at the TV. So she says, why do you need an 82-inch TV? I'm like, I don't need an 82-inch TV, but I want an 82-inch TV. Man law, man, come on, I want this TV. She's like, the wall isn't big enough for the TV. I don't care. Dude, I will pull a Texas Chainsaw Massacre damn TV in here, right? My wife, my fiance, she's looking at this, she's like, if you get that TV, I'm getting a new washer and dryer. I'm like, fine. We get up to a washer and dryer, the damn thing is as tall as me, and it's fucking green. I'm looking at this like, why do you want a green damn washer and dryer? She's like, I like it. I'm like, you only do laundry once a week. We watch TV every day. What the hell do you mean you want a $1,000 freaking washer and dryer? Each. So no, I don't have my TV. But the point that I was getting at was, as awesome as that TV was, it had a lot of damn buttons on the remote that I'm never gonna use. IdaPro. I'm out of here, fellas.
Thank you very much for presenting.
That's okay?
No, it's pretty good. I like that freshly did too. It's really good. Really good. Like the web traffic all the day.
Okay, you only go one more weekend, right? Yeah, we got everything. I'm gonna get out of this guy's way. I'm sorry.
Yeah, we're
Yeah.